Howdy. Here is a single sample t-test. Okay, here's the setup. Let's suppose that the census, according to the census, the average family in a given state has, what do we got? 4.5 kids. We've been hired to do an analysis for a business, and they're interested in whether the employees at their business have more kids than average. Right, so there's a setup for the problem. Right, we know the population mean. We do not know the population standard deviation. We're interested in whether this particular group of employees has more than average number of kids. I will go ahead to say that the sample data, we get, what do we get? We get a mean of 4.8 with a standard deviation of 0.9, and this is from surveying 10 employees. Here's the information that we get, and let's be different here. Let's make alpha 0.01. So as always, the first step is to do the rejection regions. Do the hypotheses, the null and the alternative. We're speculating about the population mean for the employees, right? We already know for the city in general, the state in general, there's our reference population. According to the null hypothesis, then, if the employees at this business are not different, then we should see a population mean of that group of 4.5 kids. 4.5 is the point of reference. We're still speculating about the population mean relevant to the sample of employees. And here, we're hired to see if they have more than average. So this is a one-tailed test, and we're going to throw a greater than in there, because it's greater than is what you get for more. So this is going to be a t-test. So I'm going to draw a t-distribution. Looks an awful lot like a z-distribution. It's roughly normally distributed. We're not going to don't have to worry about the deviations. The table, the critical value, takes care of that. I just do this for my own way to make sense of it. So for a t-test, what do we need to know to do the rejection region? We need to know the level of significance. Here's 0.01. We need to know the degrees of freedom. Degrees of freedom for a t-test are n minus 1. We had 10 families here. 10 minus 1 is 9 degrees of freedom. The other thing we need to know is that it's one-tailed. In particular, right, we have a greater than. So the greater than, the alternative hypothesis, puts us up here. Right? This is the outcomes inconsistent with the null hypothesis that there's no difference. So the rejection region will be one-tailed, and it'll be in the high-end tail. Alpha is 0.01, right? So that's 1% of the total. There's the rejection region. We'll write that out to label it. If it's over here, it's failed to reject. Final thing is I need to use the t-table to find that critical t-score. So for alpha 0.01, one-tailed, find the right column, then go down to degrees of freedom equals 9, and you will see 2.821. Let me give myself some room. So there's the critical T that marks off that rejection region. So I can say in words, right, we're going to reject the null hypothesis if what? The T we obtain, T OBT, is greater than or equal to positive 2.821. Anything out here has a probability less than alpha and would lead us to reject. Okay. Third step. Oh, that's the second step. Third step in the hypothesis testing is finding the value for T. T equals x bar minus mu sub x bar over s sub x bar. We don't have sigma, so we have to estimate it using the sample standard deviation. Again, just like with a z-test, we are going to get these two values from the central limit theorem. Right? According to the central limit theorem, mu sub x bar equals mu, right, which here equals, there it is, 4.5. This estimate of the standard error, s sub x bar, equals s over the square root of n. So what was s? S was 0.9, n was 10, right? So 0.9 over the square root of 10 is 9 over 3.16. We do that division and we get 0.29. So what does that do? That 0.29 is the denominator. It's the estimate of the standard error. The sample mean was 4.8. The population mean 4.5. So the t, there's the t calculation. The math isn't hard here. It's the logic that'll get you sorted out. 4.8 minus 4.5 is a positive 0.3. Divide that by 0.29 gives me a t obtained of 1.03. So where is our t obtained? Well, let's see. Here we go. Right, here's the fourth step. Fourth step is the decision. I take the result of step 3, put it back on step 2. 1.03 is over here. Right? If that's 0, there's 2.81. 1.03 is going to be somewhere in the middle. Now, this doesn't have to be to scale. This is just to kind of help our thinking. So what's my decision? My decision is to fail to reject the null hypothesis, FTR. I'm going to abbreviate, run it out of the chalkboard. Right? Fail to reject the null hypothesis. Then a conclusion. Whenever we fail to reject, we have no evidence. That says evidence. We have no evidence for the alternative. So we put that into words, right? Decision is failed to reject the null hypothesis. That tells me I have no evidence that the employees at this company have more than the average number of kids. We have no evidence that the number of kids they have is greater than average.